at 4.6, we have 4.7 and 4.8 to go. That means we'll review on Thursday, test on Friday. Everybody good? All right. 4.6. Recall that the tangent function is odd. That is tangent when you plug in negative x is going to change the whole function to a negative. Consequently, the graph of y equals tan x is symmetric with respect to the origin. So remember on Friday we were doing sine and cosine. Thursday as well we did sine and cosine, and now we're looking at tan. You also know from the identity that tan x is the same thing as sine x over cosine x. And that the tangent is undefined for values at which cosine x equals 0, because we can't divide by 0. So two such values are x equals positive and negative pi over 2, or positive and negative 1.5708. That's just pi over 2 put in the calculator. Mhm.
So when do you memorize all of the measurements?
Not yet.
Not yet.
Not yet.
How long do you have?
I don't know. All right, so in our chart, we have x and tan x. We're going to start with negative pi over 2. And the tangent of negative pi over 2 is going to be undefined. If we round that a little bit to negative 1.57, you get negative 1255.8. If we round a little bit more, then we just stop at negative 1.5. We get negative 14.1. On the unit circle, negative pi over 4. What is your coordinate at negative pi over 4? They're just random numbers.
Oh, it'd be the square root of 2.
Okay, so pi over 4 was square root of 2 over 2, right? What's square root of 2 over the square root of 2 over 2 over the square root of 2 over 2? 1. So this is where this number is coming from. It'll be a negative 1. If we're at 0, we're going to get 0 over 1. Remember that tan is what ratio with your coordinates? Y over x. So that's where this is coming from. This will be 0 over 1. Is everybody good? So I just want you to know where it's all coming from. So then as we go back to the positive values, it'll just change them to positive. So pi over 4 is 1. 1.5 is going to be 14.1. 1.57 is 1255.8. And then pi over 2 again would be undefined. Why did they use negative 1.57? It's because they're just getting a little bit closer right here. So the numbers in between negative pi over 2 and negative pi over 4. As indicated in the table, tan x increases without bound. As x approaches pi over 2. From the left. So I'm going to show you this really quick. So you'll see that this one is also the tangent graph, but I want to show you with the words up here at the same time. So if we go to our table, you guys can see that it's going to fluctuate. Does everybody see how it goes from negative to positive to negative to positive? That's because of this little curve right here, negative to positive, negative to positive. So what this is saying is, as indicated in the table, if I change my window to negative pi over 2 and pi over 2, and I'm going to go by, let's do pi over 4. As we approach pi over 2, the positive one from the left, so that means come from the left to the right, where does it go? Up to where? That's what it means by without bound. There's no bound. It's going to keep going forever and ever and ever. Does everybody see that? Right. That's exactly what it's saying. And it decreases without bound. As x approaches pi over 2 from the right. So the graph of y equals tan x has vertical asymptotes. At x equals pi over 2 and x equals negative pi over 2. Again, why are they undefined? Those are your vertical asymptotes. Moreover, because the period of the tangent function is pi, vertical asymptotes also occur at x equals pi over 2 plus n pi, where n is an integer. All right, so if we're looking at this, pi over 2 and negative pi over 2 are vertical asymptotes. What this little part here is saying, if we add 1 pi to it, 1 plus 1/2 is, or 3/2 pi. So that's all it's saying. Every additional pi is going to cause another vertical asymptote. The domain of the tangent function is a set of all real numbers other than x equals pi over 2 plus n pi, because all of those are going to be vertical asymptotes, so they are undefined. And the range is the set of all real numbers. Why? Because it goes all the way from the bottom to the top without any holes. All right.
By taking the amount of increase to the asymptote.
Yes. This is just the basic y equals tan x. We didn't do anything to it. Okay. So if we're doing y equals tan x, your period is pi. Your domain is all reals, except for pi over 2 plus n pi. Your range is all reals, or you can write it as negative to positive infinity. Your vertical asymptotes are at x equals pi over 2 plus n pi. And it is symmetric to the origin. All right. Sketching the graph of y equals a times tan bx minus c is similar to sketching the graph of y equals a sine bx minus c. In that you have to locate key points that identify the intercepts. And asymptotes. The two consecutive vertical asymptotes can be found by solving the equations. Bx minus c equals pi over 2. And bx minus c equals negative pi over 2. You got to get the right and the left side. The midpoint between two consecutive vertical asymptotes is an x-intercept of the graph. So I'm going to go back up to this top and show you with this tangent. So if we look right here, it says take the bx minus c. So basically whatever's with that tangent, you're going to set it equal to pi over 2 and negative pi over 2. So on this one, the only thing with tan is x. That's why you get a vertical asymptote of pi over 2 and negative pi over 2. I don't have to do anything with it. What is directly in the middle of pi over 2 and negative pi over 2? 0. And this would be an x-intercept. And if you look at this graph, here's your pi over 2's directly in the middle is 0 at an x-intercept. So that's all that's saying. All right. The period of the function, and I'll move it up in just a minute. Y equals a tan bx minus c. Is the distance between two consecutive vertical asymptotes. So tell me what the period was on this one. Pi, because what is negative? How far is it? Let me ask you this. How far is it from negative pi over 2 to 0? Half or pi. And then the other way is another half. 2 halves make a whole pi. Does everybody see it? So that's your period. The amplitude of a tangent function is not defined. So then after plotting the asymptotes, and the x-intercepts, plot a few additional points between the two asymptotes and sketch one cycle. Finally, sketch 1 or 2 additional cycles to the left and right. I'm not going here. What? Aiden, go before you come in here.
I got some more.
You're such a liar.
No, I will.
Why?
I'll go before I come in.
Are you going or what?
I didn't know what it is.
All right, same thing as Thursday. Just draw your lines where I draw mine. Your y-axis is going to point at the equal mark. Your x-axis is halfway. Every 2 is going to be pi over 2, so every 4 will be pi. Same thing on the other side. at 4, negative pi, negative 2 pi. All right, so we need to find our vertical asymptotes and then we need to find our intercepts and then some random points. So how do I find my vertical asymptotes? What did it tell me to do? So whatever's with that tangent, we're going to set equal to pi over 2 and negative pi over 2. So this is for your vertical asymptotes. How do we solve for x? When we multiply by 2, all of our 2's will cancel out. We're left with x equals pi. And on the other one, x is going to equal negative pi. If you think about it at pi, what is your coordinate on your unit circle for pi? What's your coordinate? Negative 1, 0. You are right. It is 180, but it's negative 1, 0. And you said it was y over x, right? Yes, maybe.
Oh, yeah, thank you.
Okay. But why is this one not, what's it say for this one? Why is this one not undefined there? What are we doing? Half of that, right? So what would be half of the 180?
90.
What's your coordinate there?
No, 0.
And then what would your x coordinate be? 0. So on the bottom, it would be undefined, right? Does everybody understand that? So if it's just regular tan, that's why your pi over 2's are working. And then this is why your pi's and negative pi's. So we're going to draw our vertical asymptotes. It's just a dashed line. What's exactly between those two? So remember, x equals 0 came from being halfway between your vertical asymptotes. And then we're going to label 3 down as negative 1 and 3 up as positive 1. You can do these with your calculator. It doesn't matter. Mode, I'm going to put it in radian mode because we're working with radians down here. And I'm going to do tan. Let's do this. Tan x over 2. This way I can do them all at the same time. You guys don't have to, you can just look. What values can I put in? I definitely am not going to put in pi or negative pi because I know that they're not going to work. What can I put in? Pi over 2 would be this one. What's your value? So I can graph that. What else can I put in? What's that give me? So it would be right here. And then remember that your shape happens the same way every single time. So your general shape is to go here and it's going to be like that sideways S. And it's going to go up. What is your period?
How long it takes them.
Okay, so we went from negative pi to pi, which is how far? 2 pi. So our next asymptote is that pi plus 2 pi or 3 pi?
How do you find x-intercept?
It's halfway between your two vertical asymptotes. So what's another x-intercept? Now I have two more asymptotes. What's halfway between this one?
Oh, 2 pi.
Again, halfway. What else can we plug in? What's going to happen? Remember, it repeats itself, right? Yes, no, maybe. Yes. So when I went half pi, I went up to 1. So half pi up to 1. And then the other way was down to 1. So it's going to look the exact same. Sorry, let me make that squiggle and touch. And it would be the same thing on the other side, but you don't have to do it. What's the difference in the next one? X over 4. So what should happen? What does this 1/2 and this 1/4 do? Okay, go back to this one. This is tan. What were your two vertical asymptotes that we started with? Pi over 2 and negative pi over 2. The last ones were, the last ones were, look at your paper. What were your vertical asymptotes? The first two we marked. Pi and negative pi, right? So what happened? What did it do? Girls and boys. Focus for 5 seconds because this is not a hard question. You're making it harder than what it is. So if you're looking at this tangent from pi over 2 to pi over 2, you said that it goes to pi. What's happening? It got wider, right? So that 1/2 made it not a shrink, stretch because it made it wider, right? So what's going to happen if we go to 1/4? It's going to make it stretch even more because I went from 1 to 1/2 and now I'm going even smaller to 1/4, which actually makes it stretch more. Okay, those are the things you need to know without having to look at a graph. So how do we figure out where our vertical asymptotes are? Equal to pi over 2. So take this number right here. X over 4 and set it equal to pi over 2, as well as negative pi over 2. What do I do now? How do I solve for x? Multiply by 4. That gives me x equals 2 pi. Notice how it got better. This side is going to be negative 2 pi. All right, so for our graph, same thing, go to the equal mark. And halfway. Do the same exact thing I did before. This one's going to be pi, 2 pi, 3 pi, negative pi, negative 2 pi. So it looks exactly like the last graph, so we can compare it a little bit more. We said our vertical asymptotes were at negative 2 pi and 2 pi. Make it exactly the same, negative 1 and 1. Where's my x-intercept? Why?
Because it's in between.
Exactly between. And then I'm gonna find my coordinates for the rest of them. So instead of over 2, I'm doing over 4. Sorry, that's not what I wanted to do. I apologize. These are weird, aren't they? So these were pi over 2.
How much?
Okay, thanks. Bye. Oh, you're leaving at 2:45. All right. Sorry. 2:45. What numbers can I put in here? Pi over 2 didn't work. I mean, it did, but I can't graph that, or I could. Let's try pi. Did that work? Pi and 1, which means what other one? Negative pi and -1. Our graph is not big enough to do another session, so we're gonna leave it just like this. Because that's the formula.
Yeah. Multiply the denominator to the top, you don't multiply the bottom.
All right, what's different about the next one? Got a number in front. What does that number in front do? Think about your U shapes. What does it do to the U? A vertical stretch, right? A vertical stretch makes it a little bit skinnier. So we're gonna see that. But what about that negative? Flips it. So now, right now, this one is increasing. So what's that negative gonna make it do? Decrease. All right, so let's work on it. Remember, we take whatever is here and we set it to pi over 2 and negative pi over 2. How do I solve? This is 1/2 divided by 2, which actually gives you what? 1/4. So this is pi over 4. The other one would be negative pi over 4. Okay. We're gonna make this one a little bit smaller. Just to save some time. So our vertical asymptotes are at negative pi over 4 and pi over 4. What else will that tell me? X-intercept is at 0 because it's halfway. All right. So this time I have -3 tan 2x. So pi and that is not gonna work. So what can I put in here? Let's try pi over 8. What do we get? Okay, so I'm gonna change this up. This will be -3. Pi over 8 is -3. What else could we plug in? Negative pi over 8. Sorry, I cleared it. And I got +3. So now you can see it was at pi over 4 instead of being pi or 2 pi or anything like that. And then, sorry, it's squiggly line, but you can see that it's decreasing. How did the 3 change it? The negative did, but what about the 3? That's the one that stretches it vertically. So instead of being at just 1, now it's all the way down to 3. So if I would have graphed them the same exact way, you would have been able to see that. Flip it over. Same thing one more time. Y-axis at the equal mark. X-axis halfway. The only difference in this one is what? The negative 3 is not there. Same as the other one. The negative 3 is not there. So remember, the only thing that the negative 3 changes is that very last coordinate. So all of this should all look the same. So this will give you pi over 4 and negative pi over 4. Here's your pi over 4. And your negative pi over 4. What's directly in the middle? Good. So vertical asymptotes are on the outside. Directly in the middle is 0. And then again, I told you the only difference was we don't have the 3 on it. So our pi over 8s work, and the only thing they change is we're going to have 1 and negative 1. Like we had before. So positive pi over 8 is positive 1 and negative is negative. It did not rotate it because we didn't have the negative 3. It didn't change the y values when you plugged in because it doesn't have the 3.
All of the coordinate between, like, center.
I would. All right, graph the cotan function. What is cotan? It's basically the opposite tangent, the reciprocal of tangent. The graph of the cotangent function is similar to the graph of tan function. It also has a period of pi. This should say from. However, from the identity, y equals cotan x, which is actually cosine over sine. You can see that the cotan function has a vertical asymptotes when sine x equals 0. So we said tangent has those vertical asymptotes because cosine was on the bottom where it's equal to 0. Now we're putting sine on the bottom, so they'll have vertical asymptotes where sine is 0. That occurs at x equals n pi because that gives you your y value as 0. So at pi or at 180, our y coordinate is 0. I'm sorry, our x coordinate. What am I doing? Hold up. Your y coordinate is 0, which puts it on the bottom. Sorry. All right. Where n is an integer. On the graph below, note that the 2 consecutive vertical asymptotes of the graph of y equals a cotan bx minus c can be found by solving the equations. Bx minus c equals 0 and bx minus c equals pi. All right. So you need to go back. You need to go back eventually at some point to your sine and cosine and see what these need to be set equal to. Then you need to remember tangent is pi over 2 and negative pi over 2, and this one is 0 and pi. So what would your period be on this one? Look at it real close. I think it's already told you one time. Not negative pi, just pi. How is it pi? Because it goes from 0 to pi, and then pi to 2 pi. So your period is pi. What's your domain? How do I state it's everything except for those vertical asymptotes?
The little bar.
Where are your vertical asymptotes at? Good luck.
Five.
Pi, negative pi, 2 pi, 3 pi. How can I write that general? What did it say? N pi. What about your range? How far to the bottom, to the top does it go? All reals or negative to positive infinity. Very good. Where are all your vertical asymptotes at? N pi. Yep. And then just like your tangent, it's symmetric to the origin. What? N pi. Yep. Just like your domain. It doesn't include N pi.
And any.
1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi. Yep.
So if it was every half pi, you put like 1 over n pi.
N pi over 2. 1 half, 2 halves, 3 halves, 4 halves. So there's your graph. It said to make sure to set this number, this x over 3 equal to 0 and pi. So on the last one, we did pi over 2 and negative pi over 2 because that's what you do for tangent. That is not what you do for cotan. How do I solve this first one for x? And we still get, this one is 3 pi. You'll see. All right. So this pi over 2, pi, 3 pi over 2, 5 pi over 2, 6 pi over 2. I'm not going to write the numbers out, but they're going to go the same way on the other side, and you don't have to write them out either. So we have vertical asymptotes, and I'm going to highlight these so you can see them at 0 and 3 pi. Those are your vertical asymptotes. What will there be more? Where's your next one going to be? Negative 3 pi or 6 pi, either one. Perfect. All right. What's directly in the middle? So our x-intercept is 3 pi over 2. And then what do I do? How do I put this in my calculator? I don't have that on my calculator. No, that's not what I wanted. 2, 1 over 10. What? I don't like these numbers. What numbers should I pick? You can try pi over 2. can really give me anything good. Because cotan is equal to 1/tan. It's an identity. Remember, they match each other, like secant and cosecant match sine and cosine. But no, you cannot put cotan in the calculator. All right, so this doesn't give me a good one. Say it again. Where would that be at? So you're saying right here, right? 1/4, 2/4, 3/4, 4/4. So let's try 3 pi/4. Calculator. 3 pi/4. What do we get? Why do we get 2? Perfect. We should get 1, but since the 2's in front of it, we're going to get 2. So then exactly halfway between, where would we be at? Which line? Between what and what? What's the exact middle? Doesn't matter what it is, we're going to drop down to the -2. And then it'll be like that. So if I graph it for you to see, and I'll fix it in just a second. Sorry, I forgot my scales were off. Oh Lord, they take a long time. We went from 0 to 3 pi. And we went by pi/2. So probably should draw it a little different. You don't have to. You don't have to. But it comes from down here, then goes over. It's fine though. Don't stress out. Okay. Any questions? Flip it. We are not going to do the next one. We're going to move on. Just remember, what are we setting this pi/4 equal to? I mean, x/4. 0 and pi. Everything else is pretty much exactly the same. All right, move on. You can obtain the graphs of 2 remaining trig functions from the graphs of the sine and cosine functions using reciprocal identities. Cosecant x is 1/sine x, and secant x is 1/cosine x. For instance, at a given value of x, the coordinate of secant x is the reciprocal of the y coordinate of cosine x. Of course, when cosine x equals 0, the reciprocal does not exist. Why? Because if we try to flip it over, you're going to get dividing by 0. Near such values of x, the behavior of the secant is similar to that of the tangent function. In other words, the graphs of tan x, which we said was sine/cosine, and secant, and the reason they group these together is because they both have a denominator of cosine x, have vertical asymptotes where cosine x equals 0. That is at x equals n pi, where n is an integer. So at all of our pi's, 1 pi, 2 pi, 3 pi, we have an x value of 0. So that means we're gonna have an asymptote. Similarly, cotan x, which is gonna be cosine over sine, and cosecant x, which is 1 over sine x, have vertical asymptotes where sine x equals 0. And again, that just has to do with putting their coordinate in the denominator being 0. Oh, I'm sorry, I wrote this wrong. This one is n pi. Sine is n pi. Up here, just add a plus pi over 2. Sorry. We did that in the very beginning. So n pi plus pi over 2. To sketch the graph of a secant or cosecant, you should first make a sketch of its reciprocal. For instance, to sketch the graph of y equals cosecant x, first sketch the graph of sine x. What?
Let's do that. X equals n pi.
Oh, n is the integer. Then you're going to take the reciprocals of the y coordinates. Again, why the y coordinates? Because sine corresponds with the y coordinates. To obtain points on the graph of y equals cosecant x. You can use this procedure to obtain the graph shown on the next page. Oh, goodness. Everybody good? All right, so all it's showing you, remember this curve is your sine curve. Then these little U shapes are your secant or cosecant curves. So again, same thing, cosine, and then you have your little, wherever your max and min are, you have your little U shape. So in comparing the graphs of the cosecant and secant functions with those of the sine and cosine functions, note that the hills and valleys are interchanged. For instance, a hill, which is a max, on the sine curve corresponds to a valley. Squeeze this in, or a minimum on the cosecant curve. And a valley on the sine curve corresponds to a hill or a max on the cosecant curve. Additionally, x-intercepts of the sine and cosine functions become vertical asymptotes. Of the cosecant and secant functions. Again, because they come reciprocal, so 0 becomes the bottom number. Remember that sine and cosine took this number and said it's equal 0 and 2 pi because the period was 2 pi. How do we solve the first one for x? So minus pi over 4. Same thing on the next one. We're going to do 2 pi. We're going to subtract pi over 4. This is the same thing as 8 pi over 4 minus pi over 4, or 7 pi over 4. Because that's what you do for sine and cosines. You do the same thing for secant and cosecant. Go from the equal mark. And halfway. Each one we're gonna do as pi over 2. What? Where were your vertical asymptotes? So there's negative pi over 4. Where is 7 pi over 4? What is 7 over 4? Seven over 4 is that. So that's gonna be this one right here. It's directly in the middle.
So in between pi and two.
That is actually gonna be another asymptote. We're gonna talk about that in a minute. We have 2 cosecant matches with Nope.
No,
opposite letter. Yeah, opposite letter sign. We have x plus pi over 4. Okay. What would this one be? You don't have to be specific about it. It's in between 1/2 and 1. Or 1.7 pi. What is that? Negative 2e to the 13 looks like 0, right? So we'll look at this one in just a minute. Okay. What's directly in between these two? Pi over 4. What do we get for pi over 4? 2. So we're going to go up by 1. This one is going to be 2. Let's try pi over 2. What do we get? Yeah, which is like right there. What about 0? You have the same number, right? Remember that they're making these U shapes. Everybody see that? So there's your U shape. Well, what about the next one? What's directly in the middle? What about here? What's directly in the middle? You don't have to be specific. What is the middle between where and where?
Between pi and
Pi and 3 pi over 2, right? Why was this at 2? Because the 2 is in front. So this middle is going to be at negative 2. You didn't quite go up one for each one of these. So you're not gonna quite go down one for either one of these. They're gonna match. What? Does everybody see it? The next one was directly in the middle. Okay, so our vertical asymptotes, 1, 2, 3, 4 over.
Oh, it's gonna be 1.5.
Yep, and it's gonna go at 2 and then almost 3 to look like this. And you can just keep doing that over and over and over again. But that's all you do to graph them. I'm gonna leave the next cosecant out. We're gonna do a secant graph. Hurry up. What do we do for a secant graph? We can try. We can try. Let's see what happens. Look at this. Secant goes with if we divide by 2 here, x is going to give us, but what do you notice? Sorry. What do you notice? Look at my calculator. Did that 0 cause an undefined? No. So is that a vertical asymptote?
Yeah. No.
No. Remember, it'd have to be undefined or it'd have to be an error. So why is this one different? With sine, it's 0 and 2 pi, because remember we cross at what? At the origin, right? So it's cosine cross at the origin. No, so it can't be 0 and pi. So we need to figure out what it is. We'll be there in a minute. So what if you forget? What are some good ones to plug in? Okay, pi over 4. What happened? How would we have gotten pi over 4? What do we have to have here? Pi over 2. So what do you think the other one's going to be? Let's try negative pi over 2. Negative pi over 2. Oh, didn't give us that one either, did it?
No.
Okay, so it's not that. But we know this one works. Okay, so let's graph these. I did pi over 2. This one was pi. This one would be 3 pi over 2. Same thing on the other side. So we know that pi over 4 gives us a vertical asymptote. No, I typed in the wrong thing. Had to be. There we go. You were right. You were right. I don't know what I typed in. What? We didn't do what?
You put -3 pi over 2, and it says 2 pi.
Oh, sorry. I was just looking at the other side and saw that. Thank you. We're good. All right. What should I pick now? Not necessarily that the x-intercept is 0. What happens at 0? At 0, 1, right? Okay. What other thing can I plug in? If this is pi over 4, what's this one? Pi over 8. Mhm. And we get 1.41. So right there. The other side's going to be the same way. And there's my U shape. My next vertical asymptote is either going to be on this side or this side. Doesn't matter which one you choose, we're going to do both of them. What's in the middle of this one? What do we get at pi over 2? What do we get at pi over 2? And my calculator right there, I put it up there. -1. So this one was +1. And then it went down just a little bit. So at negative pi over 2, it's going to give you the same thing, the -1. And then it's going to go down just a little bit. And just keep making those curves.
I got the one pi over 4 from plugging in random numbers and random, like,
They're not random. You have to memorize, well, you have to know what they are, but if you forget, like you don't know, should I set it equal to 0 or 2 pi or whatever, plug in those specific numbers that you're really good at.
So for secant, it's always equal to pi over 2.
Mhm.
Every single time.
Should be pi over 2 and negative pi over 2. Mhm. All right, flip it over. Damped trig graphs. You can graph a product of two functions using properties of the individual functions. For instance, consider the function f of x equals sine x as the products of the function, sorry, x sine x of y equals x and y equals sine x using properties of absolute value and the fact that the absolute value of sine x is less than or equal to 1. You would know that the absolute value of x times the absolute value of sine x falls between 0 and the absolute value of x. Consequently, the negative absolute value of x is less than or equal to x sine x less than or equal to the absolute value of x. This means that the graph of f of x equals x sine x lies between the lines y equals negative x and y equals x. So this is all just formula stuff. Don't stress about it too much. And then furthermore, because f of x equals x sine x, which will equal either positive or negative x. At our asymptotes. And that function is going to be 0 at n pi. So at 180, it's got to be, because your sign value is your y coordinate, and our y is going to be 0 times anything is still going to be 0. So that's all it's saying, where n is an integer. The graph of f touches the line y equals negative x, or the line y equals x at x equals pi over 2 plus n pi. And I'm going to explain this when I get to the graph, so just keep writing for a minute. And it has x-intercepts at x equals n pi. A sketch of f is shown below, and in the function, f of x equals sine x, the factor of x is called the damping factor. So now this sine curve, instead of fluctuating between 1 and -1, when we multiply it by x like we do, it fluctuates between negative x, so y equals negative x, and y equals x. And again, it dampens it as it gets towards 0. Okay. That's all it's saying. So it says sketch the graph of f of x equals e to the negative x sine 3x. So draw your arrow for your y-axis at the x in f of x. And then halfway here. We're going to have pi over 2, and then pi, negative pi over 2, and negative pi. I'm just going to put the function in e to the negative x sine 3x. And then we're just going to pick values. So I'm going to delete all these out. So give me a value that I should plug in. I always start on the left, just to throw that out there. What's my value on the left? My value on the left is negative pi. What happens at negative pi? Okay. What would be, what's this one? What's in between 1 and 1/2? You can do 3 pi over 4. You can do negative 0.75 pi. I don't care how you do it. What'd you get? Okay. So this goes down to 5, 6, 7, something like this. What can I plug in next? Negative pi over 2 is 4.8. So somewhere right in here. 0.25 pi, negative 0.25 pi is negative 1.55. Then we get to 0, and it's 0, 0. And then you keep going. So 0.25 pi is 0.3. Nope, sorry, positive 0.3. Pi over 2 is negative 0.2. 0.75 pi is 0.067, so it's getting smaller and smaller, right? So we started here, went up, down, up, down, and back up. So it's looking like this. If I actually graph it, and I'll fix it in a minute so you guys can see it. Negative pi to pi. We can see exactly what it looks like. And then there's your dampening when it starts getting smaller. Nope. Why does this one not get bigger? Your dampening factor to the negative x. You see it now? It's gotta stay in there.
So E makes stuff, yeah, like.
Any number in front right here. So the last one was x. So when I did x, it made it between x and negative x. So this one's gonna be between that and the other way. It'll be negative e to the x. So it's gotta flip over.
When we had numbers in front of like different things like the -3 and to that, and to that.
Yeah, because those are numbers. These are not numbers. These are functions. You are correct.
All
right. That's okay. You can ask me in just a second. These are just showing you graphs of different trig functions, just so you have them. There's nothing that we're doing with that. And then here's your homework, page 317. 9 through 14, all. 49 through 64, all. So get that wrote down.